Hello again, and welcome to the next video in our annual, yearly, whatever you want to call it, video series on C++. I will be your host, Mr. Ensminger, today showing you how to create user-defined functions. It's likely by now we have started to do some of this in class. This is just going to kind of enhance all of that stuff. So let me just start off with a little example. Let's do something with the slope of a line, right? Difference in y's over difference of x's. So if I put in 4 variables, let's say I have int x1, x2, y1, and y2. And then I will say cin x1, let's do it this way, x1, y1, and then cin x2, y2. I didn't want to do x1, x2 because that's not really how you would think of points. So I will put a little note here for the user. I will say, please enter x1, y1, and x2, y2. See how points? Okay. So once we have that, what we would normally do if I were to ask for the slope of a line and difference in y, difference in x's, I would simply say something like cout the formula, or I could even assign it a variable. I could say double slope equals quantity y2 minus y1 divided by x2 minus x1, and cout slope and L. Right. Now, a few quick things. We've talked about this before. This has nothing to do with functions, but we have 4 integers, and we're doing division. We're storing it into a double, but remember that by the time it gets to a double, it's too late. Anytime you're doing division with integers, you have to watch out. You have to be careful that you're not doing integer math and expecting a double result, expecting decimal results. So, therefore, I'm going to make sure that I typecast, put the variable type in front. And I don't really honestly need to do this. I'm just going to be on the absolute safe side. I'm going to put double the type I want before each of my quantities. So take integer y2 minus integer y1 and then convert that result into a double. Take x2 minus x1, the integer result of that, turn it into a double. Divide double by double, and it'll store it into a double. The reason I'm saying you don't need to do that is because variables have what's called promotion. If you have an int and an int, it stays as an integer. If you have a double and an int, it always goes to the type that's highest, which is a double. Doubles are higher level than integers. So do I technically need both of these? I do not. But I'm going to just put it there simply because. So let me just run this real fast and make sure you're careful about what you type in. If I type in the wrong numbers, I could get divided by 0, which I don't want to do. So let's do something like 0, 0, which is the origin. And then let me do, 4, 2. It gives me 1/2, which when you do some quick math, y1 minus y2, you have 2 minus 0 divided by 4 minus 0. So 2 divided by 4 is 1/2. You get 0.5. I'm not going to get the fraction result. I'm going to get the decimal result when I do the slope here. So all of this gives me the slope. Fantastic. So how can we make a function out of this? Well, what we do, and again, hopefully by now we've done some math class, unless you're looking at these in advance. I'm going to go up here and I'm going to make what's called a function prototype. So up here, we put basically the header of the function. So what does a function header need? First of all, it needs the name of the function. So in math class, you'd have like f of x, g of x. But in math, you're limited to single letters. X, Y, Z, A, B, C, and even for functions, F and G. But on a computer, variable names, identifier names can be really whatever you want within those laws of, can't be a keyword, something like that. So I don't have to call my slope function m or f or anything like that. I can call it slope, and that's exactly what I'm going to do. On the left of the word slope, you put in the return type. The return type is what kind of thing are you going to get out? And the reason I wanted to do it down there first is because I want you to see, like, the variable slope is going to give you a double as an answer because it's going to store it in a double. My variable and my function are not that different. Slope is going to give you a double as an answer. So on the left of the word, on the left of slope, you have what's called the function type, just like a variable type. What does it give you? It gives you a double. Then, in the parentheses, you have the parameter list. The parameters are the values, the variables, what have you, that's going into the function. They have to match in the number of them, the types, and the order. What I mean is, slope requires 4 integers. So what I'm going to put here is int, 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 int. I'm going to end it with a semicolon. That is what we call a function prototype. It has the return type, the function name, and the parameter list. And as I mentioned, the parameter list must match in number, type, and order. When I say order, my function is going to be x1, y1, x2, y2. If I do that out of order, it's going to give me a very strange result. It's not going to give me an accurate result. When I say number, x1, y1, x2, y2, there's 4 of those. So my function needs to take 4 of those. The type, all 4 of those things are variables. They're integers, so I need an integer for each of those. Okay. Notice, though, there's no other code up there. It's kind of like a variable declaration, except it's a function declaration. If you declare it here, that means you can use it globally out throughout your entire program. But at some point, you need to define what does this thing actually do. So what we do down here is we make what are called the function definitions. What does the function actually do? We have to code the function. Now, I'm going to get rid of those 2 lines because my program is no longer going to use them. But instead of erasing them, I'm going to take my formula here, take that whole thing and cut it, and then, like I said, just kind of chop that out. And now in here, the function definition matches what's up top in the prototype. So we have the return type, we have the name, we have the 4 different parameters. But here's 2 differences. Number 1, there's no semicolon because now we have braces. The braces tell us what to do. 2, I need to put names now with these. Just like there's f of x, you need to put the names. And I'm going to put x1, y1, x2, y2. As I mentioned earlier, it has to match in number, and it does. There's 4 of them. Order, x1, y1, x2, y2, and also variable type. They're all 4 integers. Okay. We'll talk soon about something called variable scope. I'm not going to worry too much about that right now, but just understand that these 4 variables up here, x1, x2, y1, y2, don't necessarily carry over down here. That's a whole thing that we'll get into. So what's nice is I can just paste my formula, and to do the math, do the calculation, and you need to send it back to the original function, to the main. Main is a function. So I'm going to say return. The keyword return says, here, do this math, and then I'm going to give the answer back to the function that called me. Calling a function is when you say, do it. And that's what we still lack. Back up here in my main function, if I put cout slope, which now pops up, and see what's nice is, if you remember from the math video, when you type the math command, up pop the instructions for like what's supposed to go in. Well, look what happened here. Because you made your own function, it pops up thinking, oh, I know this. It's not something that C++ knows itself. It's something that you define. But now it can use it. It's what we call an extensible language. It's a language that is very flexible, and you can add your own stuff to it. So if I send in the order x1, y1, x2, and y2, followed by end-L, my program now is no different than what I had before. Before I had a variable that was equal to the slope. Well, here I have a function. If I run this, zero, 0, and what was it, 4, 2? 2, 4. Okay, so it was 4, 2. But there, I mean, there you see the slope. 0, 0, 2, 4. You get 4 over 2, which is 2. Backwards, it was 1/2. Now it's 2. Whatever. You get the idea. It works. That's how a function works. And we can do lots and lots of these. The advantage is that once you code something, you never have to code it again. The idea that you don't reinvent the wheel. Okay, so let me give you one more function, and it'll be based off of something we recently did. The box of asterisks, the star box. If I type in 5, I want a 5 by 5 star box. Let's say we needed that in like 10 different programs throughout the rest of the year. If going back and copying and pasting that code is really not that beneficial. But let's say I make a function. I can just then include the function, which we'll get into later how we can make our own include functions. But if I come up here and I say, I'm going to make a function called starbox, which is going to take in as a parameter one single number, the number of the size of the box. So what comes out of it? Well, this is something, again, we're going to be talking about in class. The variable types are the returns. So like you have an integer function, you can have a double function, you can have a Boolean function. But functions that just do stuff, functions that don't actually return any kind of math, like a starbox doesn't return math, it just does its thing, just prints it out. For those functions, we call them void functions. A void function means there's no return. Hence the word void. Oh my gosh, there's the point no return. That's a void. So you're sending in a number, and what are you getting out? You're getting out a pretty picture, but you're not getting out any kind of return. You're not, you're not getting a math. You're not getting a number. You're not getting something like that. It could be argued for this one that you're returning a string, but we haven't done strings yet. So I'm just going to simply say it's void. And there's lots of times you want a void function. So to code this, I have my two prototypes up top here. In my main function, if I say I want a star box of size 10, that's how we call the function. Calling a void function versus calling a non-void function. Notice how the non-void function requires the extra couts because it needs to be printed. You need to return something. Something that's a void function, like starbox, there's nothing to be done behind the scenes. You just have to say, here it is, print it. So you don't need to say, like, store this starbox. You don't need to say, print the starbox. The starbox is printed in the function. Here's what I mean. I'm going to come down here. It ultimately doesn't matter which definition you do, in what order. You'll find it. But if I do void starbox int x, what a great name for variable x. Why not? And so here, again, when we're saying send in 10 and make one of these. Okay. For int v equals 1. V goes up to 10, v plus plus. But that's 1 to 10. X is really my limitation here. So go from 1 to v, or 1 to x. So you type in 10, it's going to go 1 to 10. Type in 5, it's going to go 1 to 5. Inside here then, for int h equals 1. H goes up to 10. Well, no, not necessarily. It should go up to x. H plus plus. See out a single star. See out end L. And now we just made a function, which, again, like the idea here, the theory here would be, okay, I've coded that once. I don't need to do it again. I know how to do it. I just go back and grab it from, include sming.h. And eventually you can make all your functions that you've done everything for, like digit splitter, hollowbox, starbox. So you can put all those common functions in one file, and then just at the top of your folder or top of your program to say include whoever.h. And there's your files. Everything's there. So, if I run this, and don't ask me why those are underlined, I have no idea. The only thing I can assume is that it's thinking that maybe it's 0. I don't know. 0, 0, 4, 2, and then here's my box. Here's my box of stars. So, how about that? So we have a non-void, we have a void, return something. Notice what's not here, there's no return. There's no return because it just does it. You're just saying, here it is, here's my star box. Okay, cool. And then you're done. So we will obviously be doing a lot more of this in class in the next couple of days and weeks to come. You really can't go too far from this because you'll get really lost. Like the stuff we're going to be doing later in like January, February, March is going to require intimate knowledge of how to do functions. So make sure you understand these before you move on. All right. Thanks for watching, guys. Take care.